Bismillahirrahmanirrahim. Welcome to the channel. My name is Asim Amjad. In this video lecture, we will discuss the concept of displacements. Basically, the concept of displacements are much easier to understand than that of stresses. This is because the displacement can be defined using the notation of vectors, and we can say the displacement of a particle in a body is defined as the vector found by connecting from its location before deformation to its location after deformation, and a displacement u bar, which is a vector quantity, can be decomposed into the three displacement components, mainly ux, uy, uz in the 3D space. Each particle in a body has its own displacement quantity, and this can be like, that is, light stresses displacement are functions of position, and the resultant displacement u is the magnitude of the vector quantity. Okay, let's first discuss the displacement in the cantilever beam. So launch the Solidworks and open the file Cantilever, which was saved in previous video lecture 1-2. Okay, now first we view the displacement for the elongation case. In that case, move to the elongation tab and click on it, and then move to the results and double click the displacement to activate it, and here it shows the resultant displacement u. Since this case is a pure elongation in x direction, the resultant displacement u is the same as us. So the minimum displacement, which is essentially 0, is at the fixed end, and the maximum displacement, that is 0.023 millimeter, is at the free end. Okay, now again move to the displacement 1, right click on it and click probe, and after opening the probe result feature manager window, select the on selected entity under the options heading, and then move to the second heading of results, and then select this edge of the cantilever beam, and then click update, and then check this flip edge plot option, scroll down a little bit, and then under the report option click the plot, and here you see the edge plot of the cantilever beam, and you can move your cursor in this way to see or to check the displacement values at different points, and you can see the maximum displacement is at the right of the cantilever beam, that is 0.023437.5, that is shown here. Okay, you can also see the displacement is changes linearly from the fixed end to the free end, and selecting any of the four edges parallel to the x direction should have the same result. Okay, now move back to the probe result section, clear this edge 1, and now select this edge 2, update, make sure this checkbox is checked, and then again scroll down and click the plot, and also open the first plot, and you can see both the plots shows the same result, 0.023, and here you can also see 0.023. In this case, pure elongation in x direction, that's why the resultant displacement u is also the same as the us. Close the plot. Now we are moving to view the resultant displacement of the bending and elongation case. First close this probe result and then click bending and elongation. and then again move to the result session and double click on displacement 1 to activate the result, and then you can see the maximum resultant displacement is 0.099 millimeter is at the free end, and it is the combination of the UX, UY and UZ. This one is the free end, and here you see the maximum displacement value. Okay, now again repeat the same step as you did before. Simply move to the displacement one, right click on it and click probe, and after clicking the probe, move to the options group and select or check the on selected entity, and first select this edge, then click the update result and then flip edge plot, and finally click the plot, and here you see the displacement plot along an upper edge in x direction, and the resultant displacement changes non-linearly, as in this case the pressure force is acting at this side, and you can found the maximum displacement at its free end is 0.09958, maybe a little bit or a slight deviation of the result at your end. Okay, now close the plot and scroll up a little bit, clear the selection of the edge 1 and now click the edge 2, update the values, make sure the flip edge plot is checked, scroll down and click the plot, and here you will see the displacement plot along a lower edge in the x direction. It is slightly different from the upper edge as you noticed in the previous chart. Alright, now again close the plot and check this OK button. Okay, now we are going to view the UX of the bending and elongation case, mean the displacement in the x direction only. Previously we view the displacement of x, y and z direction, or you can say using the resultant displacement. Now we are going to viewing the displacement of x direction only. In that case, move to the displacement 1, right click on it and click edit definition, and under the edit definition option, move to the displacement plot feature manager option, and under the feature manager of displacement plot, move to the group of displacement and select here X displacement, and make sure the unit of the display is in millimeter, and then simply click OK, and then again move to the displacement 1, right click on it and click probe, and then again repeat the same step as we did before. First select the on selected entity, select this edge, update the values, check this checkbox and click the plot, and here you see the plot along the upper edge in the x direction. So these are the displacement values of UX along an upper edge of the cantilever beam. Okay, now close the graph and clear the selection, and now select this lower edge. Then again click update and make sure this chatbox is checked. Scroll down a little bit and click plot again, and here you see a plot along the lower edge in x direction. These values are in the x direction displacement only. Okay, now again close the plot and check this probe result button. Okay, and now again move to the displacement 1, right click on it and click edit definition, and now change the display option from X displacement to Y displacement. Now we are actually viewing the UI of the bending and elongation case. And after selecting the option, simply click OK, and then again move to displacement 1, right click and select probe, and under the probe check this on selected entity and click this edge 1, update the values, check this checkbox, scroll down a little bit and click this plot, and here you see the UY plot along an upper edge in the X direction. And now again move to the result section, clear the selection and select this edge value, click update, make sure this chat box is checked, scroll down and click plot, and here you see the UI plot along the lower edge in X direction. It is essentially the same as the upper edge. Alright, now you may feel the difference in the displacement of UX and the UY. The displacement of UX is moving down to the upward in the upper edge and the lower edge, and the displacement of UY is moving upward to downward direction. This thing is done due to the pressure force is acting at this side. If you simulate this result, or you can say animate the result, then you can see, let me slow down the simulation a little bit. Now you will see the pressure force is acting at this side, and also the force is acting at this side. So this will cause to increase the length or in cantilever beam, and after the force is acting at the upper side will move it to downward. So that's why here you see the graph values are in opposite direction. Okay, let's close the result. Now save the document and click the Exit Solidworks button. Thank you.